All right, we're going to go ahead and get started. So, RapidApp. In a nutshell, RapidApp is a web development tool. It's many things, but its main purpose, its main mission is model-driven interface automation. So that means being able to quickly get interfaces that are appropriate for the real structure and meaning of your back-end database models, like your database, relational database, what have you. So, given a data model, we want to generate an appropriate user interface to interact with it. So, for example, given a database table, generate a grid. And this is rich and interactive, lots of inline capability. Given a row of a database, generate a property sheet, simple name-value pairs. But like the grid, each column is represented both in terms of appropriate rendering as well as, if editable, like this is, appropriate editing. So this is a varchar column, for instance, so it's going to give us a text box to modify. This is a number field, so it's only going to allow us to supply numbers. This is bytes, which is rendered as a megabytes field, but it's really an integer field that we can edit appropriately. And also properly representing relationships. So for foreign keys, like single relationships, we have selection paradigms, like we can have a drop-down to change the foreign key associated with that and type to search and whatnot. Given a file system or other hierarchy, generate trees. So this is a file system view, which is actually rendered by RapidApp, which is a RapidApp built tool, and it's the standard conventions that you would expect: expand, collapse, type to find. This is a database walked tree, but rich interactive capabilities, drag and drop and copy, rename, and whatnot. Given unstructured rich content, generate WYSIWYG editors and CMS controls. This is just arbitrary content, but we can have inline edit controls to be able to modify content. Even insert images. And have that take effect. For interrelated models, we generate interrelated interfaces. So, given a relational database with multiple tables, we generate a set of related interfaces to interact with that. So, there's plenty of seats at the front. I recommend you come forward because it's a little difficult to see some of these slides. We can have a navigable interface where we can browse these different tables of this database. But also for relationships, we actually can then navigate. Not only can we change the field of a relationship to something else, but then also navigate to that related object. It paints navigation links on there, and that goes for single relationships as well as multi-relationships, which are the reverse of a foreign key. And we can follow those links around. For this baked-in navigation, it's all based on RESTful paths. As we click around, these are tied to real RESTful paths, so that these can be linked to from the outside, and this is a live link here. And each of these paths are absolute and can be linked to from the outside. Even though it behaves as a single-page app, it is able to trigger and follow that navigation based on that RESTful path. And the interfaces, they're aware of their navigational context. So I don't know if you can see the difference here. On this screen, there's no little navigation icons, whereas on this one there is, and that's because it's aware that this one is within a navigational structure. This one isn't. There's also custom layouts. So far, all the interfaces that I've shown are all out of the box. We're all able to be generated automatically just from the database. But you can also supply custom templates to customize views that are still based on these same store models. So for instance, this is an example of an out-of-the-box row interface for a property page, which is name values. And you'll see here there's rich column capabilities, which I'll show a little bit later how we get to these. But these are just part of the column model, which are available for extra metadata to make a column be an image or be any sort of crazy customized thing like this. This is actually just a part of the column rendering model. But it's still just name value pairs. But we can take that same row and we can render it with a template, which is just any markup that you want, and it's the same data, the same capabilities, and it supports the same inline editing functionality directly inline. And the same goes for interfaces with multiple records. So we have the out-of-the-box interface for a table, the grid interface. Well, we can also do a custom markup to do that and render the same data as well. And the same inline capabilities, appropriate editors based on the data types, multi-selection dialogues, and so on. And then here's for that view, here's the markup that rendered that. Is simple markup. It's driven by Template Toolkit. And then there's just very simple keywords that are available to hook into actions like add, edit, delete, and whatnot, which you can just inline in your markup wherever you want, however you want, and then iterate over fields. And this syntax right here is all that's necessary to not only render the value of that field, but also provide inline edit controls, if edit is allowed in that context, to edit it inline. So we look back here, that species, for instance, the selection is all part of the column model that's available right in line. And we can save that change. So it's more than templating, though. There are common high-level client transactional models. So for instance, there's different types of CRUD modes. So one of them is related to persistence. So we have the setting persist immediately. When persist immediately is on, as you edit fields, as soon as they blur, it saves the change to the database instantly. I can add rows, they'll appear instantly. I can delete rows, they delete instantly. You can select multiple by holding control and whatnot. Now, if persist immediately is off, then instead, as I make changes, they become dirty, and there's a little indicator that gets marked in line, and then the changes don't get persisted until you click save. Or if you make changes, you can also instead undo and go back to your previous state. And then there's other combinations that are available. Maybe instead of editing inline, we edit with a form to edit multiple fields at once in a form context. And the same goes, we can add a row by going through a form. And then here's that exact same table rendered with a custom template. And all the same rules apply. This one is persist immediately, so I can add rows, they appear immediately. If I change things in line, they change instantly. And if it's false, I edit in line, and it changes. And I have to save it, or I can undo it. And then this has a confirmation. And then the same can also go, you can add rows by using a form. It's the same form, and the new thing will just appear. Or you can have it configured to add directly in line, to where I click add and it just creates a blank dummy row that you can then mark up until you save it. And it's up to you how to use these different scenarios are worthwhile for different things. All these different combinations are available simply by this different combination of settings that you can supply on the back end. And also, if I didn't mention before, hold questions to the end. What's the question?
So, is there any way to configure permissions on a user-by-user basis?
Yes.
Which settings?
Yes. Yes, that can all be configured on the back end. But these are the high-level modes. We're not going to have too much time to get into those scenarios today. But ask me on pound RapidApp, and there's plenty of ways to implement permission rules right into your model. Okay, so beyond just the data views, if you want to customize your data views, there's also lots of high-level capabilities just in the built-in interfaces. So like for the grid, there's common things, sort, there's multi-sort, where you can sort by multiple columns at once. You can, of course, rearrange columns and resize columns, show, select which columns you want to show. Of course, there's paging controls, first page, last page, next page. You can adjust the items per page, all in line, quick search. Then there's comprehensive query builders where you can build out a whole combination of rules. I can say billing city contains and the selector that's available in the query builder is based on, again, the column type. So this is a string, billing city is a string value, so I have string value operators, whereas total is a numeric value, so I have numeric tests. And all that just makes sense. And you can, build this out multiple layers of conditions of ands and ors to build out any kind of query that you want. And yes, before you ask, yes, these are savable, and I will get to that, of how these views can be saved. And there's also capabilities, column summaries, again, based on the column type. I can, for instance, total that current view, what's the total of that column, which is, again, is based on that it's a numeric type. Other capabilities, batch modify, you can select a range. Batch modify, you can do the whole set or the selection, and you can change all of those values to something else, and that just works. These interfaces are fully encapsulated. They're configured on the server, but they're generated for the client. And you don't have to worry about any of the details of the client side. All of the client-server communication is handled automatically and is baked in. AJAX request logic, server-side persistence, and whatnot. So if we were to take, for instance, our tree example, if we were to fire up Firebug and start making changes, we see that each one of these edit changes is generating an AJAX request to the server, and all that is handled automatically. So getting to these interfaces, you're probably wondering, well, how fast is it really to get to this? So there's several ways to get to the interfaces. I'm going to show the quickest, fastest, most instantaneous example, which is rdbic.pl, which is a self-contained utility script that ships with RapidApp. And this script, it accepts one argument, a DBI connect string. And so just for instance, DBI, DBI database driver name, database name is an example one I have on here. Then username and password, which is what is in my case, or whatever other DBI connect string details you'd have. And so as soon as you run that, it goes and it inspects the schema using DBIC schema loader to understand all of the rules about that interface and assembles a fully working RapidApp interface around that. On default 3500. And so there you saw I didn't do anything other than run that single command, and that was enough to get to these interfaces based on this table with all of those same appropriate rules and capabilities. We have relationship columns, foreign keys, all that stuff is appropriate. And then this is the foundation. This is sort of the initial state of intelligence that RapidApp is able to get you up to immediately. And then you can build on top of that to further customize and do whatever you want. So that command that we just ran, it is also available. It's really just a loose wrapper around Plaque interface. And there's a number of high-level Plaque classes that are available, such as the RDBIC one, to automatically assemble these interfaces. So for instance, with Plaque, for those familiar with Plaque, it's the de facto standard way that web applications communicate and work now. And it's all interoperable. So you can mount, with this simple command, you can mount this interface as on a sub URL for a Dancer application or other Catalyst application or Web Simple application or whatever you have, you can compose that in. But then building applications past that in Catalyst, first RapidApp is, under the hood, is a native Catalyst application. So all that actually is done to make a Catalyst application a RapidApp application is loading the RapidApp plugin, which initializes this environment. So you can do that with an existing app, or when you're making a new application, you can bootstrap an application using rapidapp.pl, which has several options. You can point it at a database just like we did with RDBIC, and it'll bootstrap a working application that you can then go in and customize, automatically creating the models and what you need to do that. So then the other avenue, there's RapidApp Builder, which is a Plaque-compatible OO wrapper, which simply gives you a way to, so when you build, I don't know how many people are familiar with working with Catalyst. With Catalyst, the development methodology is you bootstrap an application in a new directory, and then you edit it, yada, yada, whereas the Plaque model is object constructor, and then you return the code ref that you can mount. So RapidApp Builder provides that, that constructor OO wrapper interface. And we saw one example of that already, which is the RDBIC. But it still encapsulates the internal Catalyst application, which is what it is on the inside. And all that actually is then necessary, again, is using Catalyst, using RapidApp, and loading the plugin in the standard manner that you do with Catalyst plugins. And then you can create and configure modules. But, so interfaces are encapsulated by this RapidApp : module superclass. Every one of these interfaces, the grid, the tree, split panel layouts, they're all driven by a RapidApp : module class. However, I don't have time to obviously get into all the details of how to do that. You can play with it. But there are high-level plugins that will automatically configure these modules for you, like RapidDBIC that we just saw uses the plugin layer to automatically configure modules based on a scenario, like a grid for every source with interrelationships. There's plugin layers that do that for you, which we'll show next. And this is the most common way that RapidApp is used currently, is just using the plugin layers to get to this instant functionality. But it's all still, it's a very, very tall stack. So you have the ability to create modules yourself and customize and tweak and go as deep. The rabbit hole goes very deep. So there's these common high-level plugins for instant functionality. There's the Tab GUI plugin for automatic layouts, which we've already seen. The RapidDBIC, which is the plugin that encapsulates all of these automatically generating the grids and the tree and everything. But then there's also there's a plugin for instant user authentication called AuthCore, and one for saved views called NavCore, which gives you the ability to have this application with user authentication, with a user database, and then be able to, with these grids, be able to customize views and save them. So, and all it takes to enable these plugins is simply to add them to the list of plugins that you use in Catalyst or in RapidApp Builder. So jumping to one of our example applications, I have the example application Creature Zoo, and this is an application that is built with RapidApp Builder. And in Builder, you simply supply the plugins in attributes. It's moose-based. So this is the equivalent way of using, the equivalent of doing that in your Catalyst app is just doing that in a RapidApp Builder object. And so then there's high-level, very, very high-level declarative options which are available that control the behavior. So let's just jump into it and take a look at it. So we automatically get, by enabling authcore, we automatically get password-protected logins. And by default, when you enable out of the box, and it will automatically initialize its own persistence database, its own user database will all get set up for you. And by default, the username admin and the password pass, which you can, obviously you can change later. So we've seen bits of this interface already, snippets of it throughout the talk. But here's the idea of this is here we have a dashboard, and these are plain, these graphs, they're just plain JavaScript. I use chart.js, which I grabbed in a couple of hours, like let's put a chart on, and downloaded chart.js. There's lots of Canvas-based tools you can use. You can put in whatever kind of JavaScript and HTML that you want and integrate them. Because of, for instance, the way the RESTful navigation works, you can have like click events, like I made it so that you can click on one of these things and have it go to the appropriate object, which is able to happen just because, again, it's the RESTful path. This is record 1 of DB species, species 4, and so on. And so we have the idea of this little silly example application, Creature Zoo. We have creatures in our database. And so we can go through and look at them. We can double click to open the view. And so this is, this is an automatic out-of-the-box grid. But then we, for the record view, we gave a template. And by the way, this is a real cat. And this is his real weight history. And so there's like, to showcase some sort of cool examples, this is all this other stuff at the column level is rendered by the column model, which is very powerful. So like this chart, which we'll look at in a second how this works, is actually just a column with a custom renderer. And then there's things like virtual columns where you can very quickly, like I have this little quick log. Let's say I want to log a new weight for Fatty. He weighs 23 pounds now. I can just type that and it updates right in line. And I'm not doing anything special with that other than working with the column model. So let's look at what that looks like. So you have, after you, for RapidDBIC, once you load the RapidDBIC plugin, it then needs to talk to a DBIC schema model in Catalyst. And again, if you are not if you're familiar with Catalyst, you already know exactly what I'm talking about. If you're not familiar with Catalyst, you can build a new app with rapidapp.pl, and it'll automatically create this file for you based on the supplied connect string. And you can. This is the standard connect details. But then you can also supply this other optional configs under the RapidDBIC config key in the model. And this allows you to customize high-level things like specify a different grid class than the default, which you can simply extend the default and supply your own module for the grids. Then there's grid params. The star defaults key is supplied. It's the constructor params that are supplied to every grid. So you have, if there's 20 sources, it'll get all of them will get the same options, which these call spec options are a simple declarative way to specify joins for all your CRUD operations. So the default is just all local columns, which is star, but then you can supply joins simply by specifying a list of relationship path names. And again, this is all based on DBIX class. So here we're saying that we want to, by default, for all of them, we want to allow everything. We want to allow update, create, and destroy for all local records. But then for creature, we want to also join all columns in the through the species relationship, and then we also want to then join out through another. We want to join through the species relationship, then through the diet type relationship of species to the CLS column. And why? What is that for? That's just so that it can show this little picture for the species. So if we change his species, change him to an orangutan, now he's a herbivore, and that just happens like in the diet types table. You see that I have this little CSS field, which I then just hook into in the template to set the CSS, which is just one example of you can do whatever you want with it. But then, so in the grid, we see that all those other columns that we join to are there in the grid there for us, including, as you can see, the chart, which is just a column. So then coming down after the grid params, the table specs section is where you specify additional metadata that applies to sources and columns. And this is metadata that's not necessarily directly related to an interface, but should be used in all interfaces, such as display column, which is which column to show when we're rendering like a drop-down list that represents another table. Which column are we showing in that drop-down? And when we type a head search, which column is it searching? That's controlled by the display column for that source. And then columns, we can specify initial default headers, and then there's different profiles where we can hook into other functionality like the image. We have a high-level profile called CAS IMG, which turns it into an image that you can, it's just a varchar field in the database, but if you give it that profile, now it's an image, and it will automatically store in the, it has a content address storage for rich content, and it just automatically hooks in and works. And you can define things as money. It'll set a money renderer, HTML, WYSIWYG editors, and whatnot. And then we also have virtual columns, as I was mentioning. So the weight chart, for instance, is a virtual column which is declared, and it's simply just a subselect that we're specifying. And so it just that column will then return the result of this, which is just getting a set of data in a string that then in JavaScript, then you can write a renderer to go along with that data to then take that data and do whatever you want with it. So for the weight chart, for instance, where am I? Yeah, we simply specify a renderer which then is able to take that data and then turn it into whatever. And that is the whole interface that's necessary to enable that rich interactive interface is simply that virtual column and that JavaScript renderer. So that sort of shows you the range of what you can do with it. And again, all of this stuff is available. I'll have a link at the end where this whole slideshow is an active application, as you can see, and you can download this stuff and try all this stuff yourself. So we enabled, in addition to auth core, we're able to log in. It gives us these logins. We also have the ability to have saved searches. So you see I have some saved searches up in here that already exist where there's some existing settings. And so is what this lets you do, when you build up some complicated combination of filters that you want, and if you can't find, you can type to filter. And by the way, you can, for foreign keys, if I want to search on that, I can have the special is value, and then I can actually select from that related object to say in my query that I want the diet type is 2, or the the species is Bengal tiger, for instance. And once you've built these things up and you want to persist the state, you can say save search. And this is an existing search, so it'll give you an option to save as a new search. And then once you save it, it'll immediately appear over here in your My Searches so that you can come back to it any time. And then if you're an admin and you want to be able to publish these views to other users, you can go into Organize Nav Tree, and you can just simply drag the search that you did out of your section and under the public navigation tree, and that instantly takes effect. And that's there now. And now I've just published this view to all users of this, and it's just free. So that's an example of some of the things that you can do. So moving on, so the custom data view, what was necessary to get to that, here's a module class that does that. We have the DBICDV, and all that's really necessary, we have our persist immediately settings that you can set here. That's where you can get to all those settings. You specify the result source that it needs to talk to, but then really we're just saying here, use this template, and here's the template include path, which is just, this is a CPAN distributable app. So this is just the shader to be able to get to that template for where it is, so it actually can get installed in your local system. And then some other settings that are also declarative, like the item selector, where we declare what is a CSS class that is going to encapsulate each row, so that when you click on it, it knows if I'm clicking on a specific thing and highlighting it and selecting it, it knows which, where the borders are for that, and when something is selected, what class to apply to that. And like this is, we'll apply this checked class. Will give you, for instance, I can click, and that now turns that checkbox on, and I can hold in control. And actually, this one does not have multi-select on, which is an option. But it simply, that's how it knows the boundaries of which record is which, and that's how. And then it can still just be simple markup. Then using this as, again, this application uses RapidApp Builder, and the way that you use that is, and you can, again, do this in any PSGI structure, you just instantiate the object and return to app, and then you can just call Plaque up. If you name this app.psgi in a directory, you just Plaque up, and then this will run. Or you can mount it in the scope of another PSGI structure. So this SlideShow itself is a PSGI app. And here it is. And the SlideShow itself is not anything special. It's actually just a HTML JavaScript that I downloaded online to give me slides that I could advance forwards. So it's just, I just used as an example Plaque Builder to just render to just render these files, and this is what that is. It's nothing to do with RapidApp. But this CodeView that's showing this PSGI file is generated by RapidApp, actually by RapidFS, which is a RapidApp tool that's also available on CPAN, which is a tool for file systems and gives source code views. So actually here's the markup of the previous slide. All that I'm doing to embed these interfaces throughout these slides is using iframes. And we're just using a relative path because of where that, or the RapidFS application is mounted. And if we come forward, we can see here's the overall PSGI structure of this whole SlideShow application that I'm running. So like you'll see here, we're at /slides, which is where the SlideShow that we just looked at, which is the SlideShow we just saw. And we're mounted using Plaque Builder, and we're mounting that there. And then we're mounting these other example applications. So like FS is mounted on fs.psgi. We can open that. This is all that's necessary to instantiate a new RapidFS app. We're just telling it what paths we want to include. And so like we can actually look at that. We can go straight to one of these paths, /fs. And there's the RapidFS and it has methods to be able to get in to view the source view, and that's what we're using to render that. And the creature zoo here, that is, which is the same thing that we just saw a moment ago, and we're simply mounting it. We're mounting it under /czoo, but it doesn't. Notice here that this config doesn't know anything about where it's mounted. It's just its own root app at its own spot. And this is another important thing of what RapidApp gives you, is it understands its structure within a PSGI structure. So if you mount an application on /czoo, on /fs, on whatever you want it to be, it automatically knows where it is. And so when it renders all of the all the HTML tags, link tags that make all this stuff work, it properly prefixes everything and properly knows where it is. So RapidApp not only knows where it is within its own structure for its baked-in navigation for rendering links to other tabs or not, it also knows where it lives within the structure of another app. So that allows it to be very, very flexible. You can mount it and it will work right. So questions? So the question is, will the tree view work with a self-referential table? So the answer with RapidFS represents a file system. And so it understands files, directories, and symlinks. And so it won't, recursive symlink, it will not follow a symlink, it'll show it as a symlink. For the tree, for the navigation in here, it is designed to not, you don't want circular references in the tree. However, you could certainly write a module that did that, and then you'd have to determine how you wanted that behavior to be. It would just endlessly, it would do what anything happens if you follow a recursion, you just endlessly expand if you wrote it to do that. So you could certainly write a module to do that. The pre-built modules are designed not to do that because circular references are usually not good. Does that answer the question? The change process. Okay, so good question. So I like to follow what I call model-driven development, where I start an application by building the schema, and I actually write it in. And different people do this different ways. Some people like to write in the write DBIC classes first. I prefer to write actually DDL for a target platform like SQLite or MySQL. So I'll write the tables in there to do that. So during development, if you now want to generate that, you have a script, you use schema loader, and after you make a change to your DDL, you simply re-import it and regenerate your schema based on that. And then I actually have a script. So for instance, for developing Creature Zoo, I wrote a script to help me do that regen schema, where I simply, I pull in, here's the SQL for that file. I write, this is the whole DDL for that. And as I make changes, I'm like, I'm going to make another change, add another column. Regen schema will just overwrite that and then regenerate the DBIC schema classes. And this is all, by the way, this is the same capabilities that the DBIC ecosystem already gives you. Now, once you've deployed an application and you have data that you need to preserve, now you need to do a migration. And for that, you can use Fru's excellent deployment handler, which will actually allow you to set up revisions and deploy them, and it'll actually convert your data and do the appropriate thing.
Does it have any mobile or tablet-ready views?
So there isn't, the interfaces that are generated in RapidApp are desktop optimized views. However, part of the point is that doesn't stop you from, if RapidApp is flexible, you can still create your own markup that is ready for mobile. And you could certainly render, if you write a mobile-ready markup, you could certainly use one of the custom data views and have that render for mobile. Or you can write your own separate controllers that still access the same database. At no point does RapidApp, tries to be available but not in the way. So it gives you extra stuff, but it doesn't force you to do anything at any time. So the front end, currently it generates XJS, EXTJS. That's what the grids are rendered by in the front end data store model. But this is, the plan is to expand that to other different front end technologies and to have different machines. Right now the XJS one is the only machine that's available, but the API that's provided is meant to be declarative to where it doesn't matter what we use. Like for the API that's provided, as long as I'm giving you a grid with sortability, with the features that you want, who cares whether I'm using XJS or Amber or XJS 6 or whatever to render it. So right now it's XJS, but the plan is in the future to add additional front-end machines to do that. So no, not yet. But I went to an excellent talk yesterday about Phantom.js, which I plan on. RapidApp has a test suite. There's RapidApp : test, and there's lots of different transactions are in test coverage, which are sort of done. I do it like in Firebug, and I simulate different request scenarios and then test those requests. So the different CRUD actions are tested, but no, I don't yet have physical testing that goes and clicks on this node and make sure that it operates. But that's the plan eventually. But all these things, would you like to help contribute? Maybe you could add some help to front-side testing.
There's a lot of data on that creatures grid. How many queries does that take? You've got those charts and stuff.
The question is, how many queries does it take to render this view here, to do all of this stuff right here? And the answer is one. One query per page view always. And that's also how RapidApp is able to be scalable. It's able to work. We have applications with up to 10 million rows. And part of what RapidApp is aiming to do is it's using the power of a relational database for a relational database. And it has these, so we rely on the database to do our sorting, to do our paging. We construct the appropriate queries to do that. And the way that we do this complex data, like how is this complex data set able to still be one query? And the answer is it's a subquery. And that's what the virtual column does, is it's as I showed you, it's a group concat. So it's still in one query. Now, it's maybe more expensive as a subquery, but it's still one query.
How does the RapidApp handle things like distributed data structures across multiple systems?
So we don't, Elasticsearch, Mongo, and document-oriented databases and whatnot, we don't have modules yet for those types of backends. I'd like to do that. As far as distributed, it's the same. Right now, it's simply the same rules of talking to the database, of talking to DBIC. So if you were to set up some kind of replication system, like if you're setting up obviously replication like in MySQL, then that's transparent. But if it's still DBIC. You can still hook into the actions in the back end of your DBIC schema to do custom operations in the same manner, the same rules that you interact with DBIC in any application. So the answer is there isn't any specific distributed capabilities on the RapidApp side, but that doesn't mean that you can't have your back end handle those things however you want.
Trying to grasp where RapidApp starts. What's the first thing that it sees? Is the first thing that it sees is the DBI call, or can it see even deeper into the database itself?
So we have the question is what does it see first? Does it see the database, or does it see deeper into the database? And that was a poor regurgitation of your question, but I'll still try to answer it. So there's RapidApp modules which encapsulate a model. And so whatever model it represents, those are the rules that it's going to live by. So the grids that we're seeing here, they are all using a DBIC grid module. So they then talk to the API that is provided by the DBIC result class. So whatever it is able to see, that's what RapidApp is able to see. Does that answer the question, or is that not?
Well, for example, let's say the difference between the underlying database, Postgres versus MySQL. Would RapidApp be able to see that, or would RapidApp simply see, the DBIX class interface?
Right. So in terms of being vendor agnostic, so there's some things that pierce through that we do. Everything should be vendor agnostic, and you should be able to take and change it from being on SQLite to MySQL or to Postgres, except one place, which is the virtual columns, which are specific to the engine. So if I go back to, yeah, and we have greatly improved Postgres support thanks to Andy. What am I looking for? So the virtual column, this is not going to work on a different, this is using concat, this is double pipe, is concatenation in SQLite. If you want this to work in MySQL, you have to change this to the concat function. Places where you implement that, and like right here, age and years, that won't work if you move to a different database platform. And then some of the question is, well, why are you doing that? There's other ways. Don't you know you can use DBIC to do these things in an automated fashion and whatnot? Part of the reason that it's done this way is so that it can be this lean inline sub-select. And that's how it's able to be, and it's able to be sorted. So like age and years, which is this sub-select function, when I go into the interface, if I can sort by age and years, and it's sorting on that sub-select. So that's why we do it that way. So if you change your database backend, that's the thing that's not portable. But other than that, everything should be portable. Well, you can implement, the question is there a way for a column that gets data from another source from the outside? Part of the challenge, part of the theory of RapidApp is we want these columns in the grid, we want them to be full behaving citizens of the table. So we want them to be sortable. We want them to follow all the rules as any other column would. And so as a result of that, we rely on, for the virtual columns, we rely on them to be through the database. So, but you can have, any function that you can call in your database, whatever it can return. So certainly, if you have a plugin and you return some outside source, which there's plenty of plugins for your database engine, then you can certainly do that. Now, for the single page view, you can render whatever you want and call, you can call methods. You have access to the Catalyst context object. You can call methods directly on, directly on the schema, and you can, call custom Perl and render that. But that's not going to work in the sorting context. But, you probably wouldn't expect it to, to be able to do that. Many to many, right? So there's three basic types of relationships, and by the way, we're at time now. So if you want to leave and go to the next thing, that's fine. I'm going to say thank you very much. Right? Well, all right. Hold on. Yep. Okay. you can, and then I'll answer your question for people who want to stay. And this will be available. I'm going to update the information on the talk. But the whole repo, if you want to run this whole slideshow, you can simply just run these commands right here, just a clone and install deps and a Plaque up, and you can run this and try it. Yep. And this is going to be I'm going to update this on the main talk page. But now to answer your question, there's three main types of relationships in DBIX class. There's single relationships, like belongs to, many relationships, has many, then there's many-to-many, which is a relationship bridge, which isn't a real relationship. But there are ways to represent it, and we do have ways to represent it. So for instance, that scenario that you're asking, you can go into the user table management and, for instance, setting roles. So I can select several roles and it will choose those. So I can say, and this is a many-to-many, and this is rendering as a comma separated. And so that does the thing that you want. However though, the caveat is there are lots of different, it really depends on the schema, on how many rows on each side you're dealing with. Something that works for this structure isn't necessarily going to work for every structure, because, like this interface won't, if there's 10,000 rows, that's not going to work. So we're working on adding other ways to handle many-to-many, but the many-to-many relationship bridge, it's not a simple question and it's not a simple answer. But yeah, I mean, all these things have been, thought of and considered and worked on. Other questions? What was your name online? Okay. It's more automated account creation. Oh, right, yes. So the question is about automatic. I think that what you're referring to is having automatic sign up, right? I'm wanting to add a plugin that allows you to expose automatic sign up. So people can sign up and create their own account. And so these are all these things, by the way, can be done already, right? It's not, you don't have to wait for me to implement it to do it, but I continue to try to add new features and new high-level options to be able to get to some of these things automatically. And that is one of the things that I think would be worthwhile and I'm planning on doing. Sure, yeah. Other questions? Yes.